Hi and welcome to Data Garden. Thanks for checking out my video. I hope you're doing very well. This video is a direct follow-up to my last video and the final one in this little mini-series of dealing with missing values. So if you haven't seen the last video where I introduced the mice package for multivariate imputation, then I highly recommend that you watch that one before this one. But if you are already familiar with the mice package and you just want to improve your fill-in values a little bit, then feel welcome to stay right here. And I will put this code down below in the video description. So one thing that is a little bit tricky with this package, mice, is that it actually makes use of randomness. So we have seen, for example, here that the 19 was put in for the missing value, but depending on your random number generator, it might also be a different value, depending on the state of randomness in your R software. And that is sort of appropriate because, yeah, the reality is that we don't know what the missing value is. And we also have an sort of an incomplete data set typically. And so it's hard to estimate what the real missing value is. And if we draw a different random sample, which is what the mice algorithm does, then we come to different conclusions. And we can also actually see that the package has taken 5 different samples and has come to 5 different conclusions as well. We can see which conclusions by opening the mice ozone list that we have created earlier. And in there's another list called IMP or IMP. And there we have a data frame called humidity, and I'm going to open that one. And there we see that the first predicted value was in fact 19, but for the second sample the predicted value was 60, then 23, then 19 again, and 19 again. Now, what do we make of that? My proposition is the following. Why don't we take the median of all the 5 predictions and fill that one in instead of just randomly taking one of the 5? Now, in this case, of course, the median would also be 19. So how we do that is with a double for loop. So I'm going to start by creating a new object, and it will be called ozone underscore mice underscore median, and I'm going to define that as ozone underscore original. So it's just a copy of the ozone original dataset with the missing value still in it. And then I'm going to create some extra lines here, and I'm going to create a new for loop. So for, opening bracket, I in 1 to n row ozone underscore mice underscore median. And after the 2 closing brackets, I'm going to create a set of swung brackets, and I'm going to create a new line of code within these swung brackets. And then I'm going to add another for loop. In this case, the variable is going to be j. So for j in 1 to n call, opening bracket, ozone mice median. And after the 2 closing brackets, I'm going to do another swung opening bracket. And I'm going to create another new line. Now, if you are not so familiar yet with for loops, then I have also made a video on that you can watch, and I will put the link for that in the description. But let's continue here. So the plan is that in this data set, we are going to go one by one from row 1, column 1, all the way to row 366, column 12, row 1, column 1, row 2, column 1, row 3, column 1, and then eventually row 1, column 2, row 2, column 2, row 3, column 2, and so on, and put the median of the predicted values in. Now, if there is no value to predict because the actual value is there, then the prediction will just be the actual value. So there's nothing to worry about there. So how we do that is we are going to take the ozone mice median object. I'm going to copy the name here and paste it here. And I have to add the square brackets here in the end. So ozone mice median, and then in square brackets I'm going to type I, comma j, which means that we select row I and column j. So first the row, then comma, and then the column. And we are going to redefine that selection as the median of a vector, so that is the command C. So we have now two closing brackets here. And that vector we fill with the following. Now it gets a little bit complicated. I have to copy here from line 53 the complete command, complete of mice ozone. I'm going to copy that and put it within the C command. But before the first closing bracket here, the first of the three, I'm going to type comma 1. What this means is that the first set of values is going to put in instead of the missing values. And in the following, we're going to replace this comma 1 also with comma 2, comma 3, 4, and 5. And now comes the tricky part, sort of. After the first closing bracket of the 3, we have to create a set of square brackets and type in the same I, comma j as we have here beforehand, because we want only the value ij out of this data set that would have also been created here. And then after the square closing bracket, I'm going to type a comma, because what that does, the comma, is it separates the objects in the vector within the C command. And now I'm going to comment this whole bunch of code, starting with the complete and finishing with the square closing bracket. So I'm going to copy that, and after the comma in the C command, I'm going to create a new line, and I'm going to paste, and I'm going to replace the 1 with a 2. And then again, after the square closing bracket, I'm going to type comma, new line, paste, going to replace the 1 with a 3. After the square closing bracket, comma, new line, paste, replace the 1 with a 4. And finally, after the square closing bracket, comma, new line, paste, replace the 1 with a 5. And this time we don't put a comma because this is the last value of our vector. Now we can run this command, and I think it's going to take a few seconds. And there we go. And if we now open the ozone mice median data set, we see also here that 19 has been filled in for the humidity. Now, to make sure that it is actually the median and not just the first observation, we can maybe search for one observation where the median would be different. And that is, for example, here the line 28, where in the ozone mice fill, we have received a value of 26. But the median, if I see it correctly, would be 19, because it comes up 3 times here. And if we go to line 28 here, then we see that in fact here the humidity has been filled in with 19. Now keep in mind that due to the randomness of the algorithm, you might get different values here. This is nothing to worry about. It doesn't mean that like my values are wrong or your values are wrong. It's just different due to the different state of randomness in your R software. But if we look again here at the where all the missing values are predicted, we see that, for example, here the 19 has been come out of 3 different random samples. So I think we can say with a certain security in our statement that the 19 is maybe more likely to be the actual value than the 26 or the 21. Similarly, for the line 50 here, the median of these predicted values here is 79. So I think we can say with some certainty that 79 is a better value to fill in than the 67 or the 90. And that is exactly what we have done here. And so if you use this technique to fill in your missing values, I think you can have quite some confidence that your technique to fill in missing values is appropriate, and that then for your continuation of the project, maybe your machine learning program that you want to develop, you can rely with more security on the values that you have filled in. So I hope that you have found this helpful, this whole little series that I've done on missing values. If you have, then I would be very happy about a thumbs up and also about a subscription, because I have more R-related content coming up very soon. And if you have any comments or questions regarding this topic, then leave them down below underneath the video, and I will read every single one of them. So I hope to see you in some future videos. Until then, thank you for watching. Have a great time. Bye-bye.